So I'll sort of start off with what my pitch was originally. What I did at my school originally was a woodshop class, actually. Is it going here? So with my woodshop class, I started with my after-school class, was not the traditional thing where kids go in and make a woodshop like a birdhouse. For me, it was, my thought was that they would actually, I'd ask the community in my school, I'd say, does anybody want something built for their classroom? And then I'd send 2 kids to that classroom teacher, and they would build that, they would do a plan work, and they would build that thing for that classroom teacher. So if they wanted an organizer, or a shelf, or a bench, or whatever, they would actually go to the teacher. So here's some of the things that we've actually built for them. So here's an organizer with a custom scissor holder. We don't kid around, okay? Here is a shelving unit. This is our librarian, because she has all this counter space but no shelves. And just one more. This was actually the very first thing we ever made, which was a bench, because when I first did this, no one responded. So we actually had to sort of go, what can we do for the community? Because I wanted to get kids away from thinking about me, because middle school kids do that. I wanted to think, the outside world. But then as time went on and people saw these products, they were like, oh, maybe I could have some things. So here for this teacher, there was this, she really loved this cart, but it was a cart that had steps in. It didn't have a surface, so we actually just built a platform for her surface here. And now she has this for Elmo and all of her stuff, and as you can see, she's quite pleased. In our main lobby, all of this, our packages, when they come in, were literally just piled up in the corner of the lobby, which looked pretty ugly. So we built this shelf unit here. I thought they'd actually put them in the shelves. But anyhow, it's much better than it just being, dumped on the floor. And here the music teacher wanted this bench. She first used it for kids, but she actually liked it better as a place to put her instruments, because the music room was taken over by a classroom, so she then got transferred into the auditorium, had no storage space. So I took this concept of the woodshop class and transferred it to a 3D printer. So I thought, like, well, rather than building stuff out of wood, what if we started making things out of a 3D printer for people? So that's where the idea came from. And I thought it'd be kind of cool, like if people had missing game pieces. Like kids always fight over that, if we have a really cool game, it's really awesome. Oh, but we lost that one piece. Well, we can print out another one. Or there's that one really cool Lego piece that everyone fights over. We can print out another one. So I went to Aubrey Love at the high school, who was our sort of guru with printing, because he's had them for a few years. And he has this one here. He actually has 10 of these. But this one has a dual extruder, so it has 2 colors, which is great. And so my first customer was this teacher here. So she has this second grade teacher who has these classroom caddies, but one of these cup things she actually lost. And you can't go to the store to get just that one, because of course it's very unique. So I took one of these things, measured it out, and that's the one that I printed for her over here. And it seems pretty simple, but it actually is quite nice, because otherwise she just has this empty gap in that space. So I'll walk you through the process that I use to do these. So the website I use is actually Tinkercad. It's a pretty simple website, because I was gearing this towards, I think, 3rd, 4th, and 5th graders, maybe middle school as well. SketchUp is another website, but I liked Tinkercad because the interface is very simple. So you make a cylinder, you sort of grab another one of these cylinders on the inside, but then you turn it into a hole, which then hollows out the first cylinder, and you basically have your object. Now for me, this spring was more a getting to know you process with printers, because they are finicky machines. So it was I just wanted the mileage. It wasn't so much the finished product, but it was just the experience with the printer. And then you print out an STL file, which is a pretty universal 3D printer file. So I thought, it turns out my printer doesn't read STL files. So this was my first oh dear moment I had. So I went back to Aubrey and I was like, what do I do? And he suggested that I use MakerBot software. So even though I don't have a MakerBot printer, I use the MakerBot software, because what that does is that it takes the STL file, converts it to an X3G file or something like that, which my printer can read. And this is also the place where I can say if I want it in red or if I want it in white, because I have the dual extruder, which has the 2 colors. So this is where I would do that. This space also has this handy dandy preview button, because this then tells me about how long it will take, which is also helpful. And this is again those things where I'm learning for exposures, like, well, how accurate are those time estimates? So as I print these things out, I've been keeping a journal for each one. It also has this thing, which is actually very cool, because as you drag this thing down, it sort of does the print job in sort of time-lapse photography style, so it can actually show you what it's gonna be like as you're printing it through. Because sometimes when you design something in Tinkercad, you're like, wow, this is awesome, but then when you put it through the preview, you realize, oh, that actually isn't gonna print out right. So it's a very good sort of testing environment here before you actually do the printing, because as you can see, this is 4 hours and 9 minutes. You don't want to print something for 4 hours, and then you find out, oh, that didn't work out, which sometimes you find out anyhow the hard way. So that's the way I sort of go through things. So this was the first thing I did. Then I had some of my 8th graders, I sent them into Tinkerbot, I had them learn it, and I said, just make anything, because I want to just get mileage with the printer so I can get used to it. So they invented some interesting, oh, that's my finished product here, so that's the cup. And this over thing here is called a raft. The cups are actually built on the rafts themselves, and the raft serves 2 purposes. It keeps the cup in place as it's printing, plus it allows you to take it off the platform more easily once you're done. There we go. So here's some of my 8th grader projects. As you can see, kind of bizarre. And this is the printout. It looks like a bad makeup day. But what it is that when you have these things sort of in the air over here, it actually builds these things here as little support structures. Because as it prints up, because it prints up as it goes. So if you have something in the air, it needs something here in order to print something up there. So what you do is that once it makes this, you just pluck that stuff away with your finger. Sort of just, you know, it comes off very easily, and you just sort of scrape it smooth with your nail, and you have a finished product. So this is what it actually looks like when it comes out of the printer. I don't have the finished product picture. So that was Mary's thing. I'm not sure what that is. Here is a little snowman, and again, this is one of those experiments. We have the snowman here has pretty thin arms. We weren't quite sure if these were too thin or if it was an okay too thin. I don't know. It was 3 millimeters big, so it printed out fine, but what we learned is that here are those support structures again. As we took the support structures off, we actually broke one of the arms. So we're like, okay, we learned. So I'm guessing we're thinking that 5 millimeters is actually as small as you really want to go. So next fall, I'll actually have an after-school program, but I'll do this a little more full speed. And these are one of those sort of guiding, you know, things I'll mention to the kids then. Also, thing we learned was when you make something that's circular on the bottom, when you put it on the table, it falls over. That's kind of like a, but that's me like, oh, forgot about that, right. In here, you can kind of see the honeycomb thing. This is what it does on the inside. These are the fills. It's not a solid plastic blob. You can make it that way, but by default, it gives you a honeycomb thing on the inside. And those, of course, are the structures there. Here's a car-ish thing. And this is one of those times where a kid designed a ring here around this semi-sphere. If you notice over here as well a little bit, there's this ring. But the finished product, the ring is not there because in the design process, he designed these rings there, but he actually didn't have them attached to his car. So the printer printed it out, but once we scraped away those little support structures right here, the ring came off. And we're like, oh, 2 things now. So again, this is one of those things you learn as you go. It's like you really need to make sure that everything's actually attached. So in your design, it looks really cool having these different parts there, but if they're not connected and attached, it won't really work out. So that's the car. What else do we have? Ah, this is part of the 8th grade wind turbine. Thingiverse is a website that has tons of projects, so we were actually, wonder how these things actually print out. So we downloaded one of them for the 8th grade wind turbine, because the kids were all making turbines anyhow right now. Just curious to see how this one would come out. It actually came out pretty well. It didn't quite fit exactly how it was, but it was kind of neat to see how it would be, and it didn't take that long. This was my tallest thing. It actually ended up being about that tall. And what else do we have? And here's another sort of specific request. You'll notice here on the top, this is one of those things where I'm sort of learning as I go. On the sides, this is a big die. This one's about 4 inches wide. And on the top, it's a little, the top didn't come out so good, so this is one of those things I kind of have to figure out and tweak the printer. So this is Matthew here. He's in kindergarten in our CLC class. So one of the teachers in the CLC class has another student, Tom. Tom doesn't have great fine motor control. The teacher often does math activities with him using dies, and she has him count out the die, but the die is too small, the holes for him to feel it. So she asked me, can you make a really big one that has very defined holes so he can actually feel them? I said, sure. So Matthew came by and helped me design that. So Matthew's actually the one who decided how deep to make the divots, where to actually place them, so he was actually making something for his classmate, Tom. So, now he's my head engineer. And up here, these are two little dies, because before I made this one, because that actually took 7 hours, I wanted to make sure that it was gonna print out right. So I scaled it down and made 1-inch version side. This one I haven't scraped off the little bits first. This one is a clean version. So I just made these two pretty quickly. Those are only about a half an hour each. And I just gave them to a class just for fun, before I made the big one. And so it worked out pretty well, and it's of course working out quite well with Tom, because you can definitely feel those things. But this is one of those things where a teacher actually requested we did a custom piece for them, and that's exactly what I was hoping this project would kind of be. So for next year, I think is my last one. Yes. So next year, the few other projects we have in the works now is a pencil holder for another class that a first grader designing for an 8th grade teacher. Matthew there wants to make a custom domino set. He's inventing a game, so he's going to make some domino pieces for the game he's inventing. We have a nameplate for one of our 6th grade students who's rather artistic. And we had a sundial that was a downloaded thing, but it looked very cool, so we were thinking of downloading that and actually printing that to see how it goes. And in the fall, like I said, we're having an after-school class, probably around 10 kids, to see how that works. So we design after school, but then I would print during the day, because it just takes about between 2 and 6 hours for each print job. And that's about it. That's my day.
So I'm going to suggest